of sine and cosine. So the value beside your function is your vertical stretch or shrink. So of course it is a stretch if a is greater than 1, and if it's a shrink, your a is less than 1. This is also serves as the amplitude of your graph, so it will be the height of your graph. Of course, you have B and C here, which represents the phase shift. And phase shift is equivalent to C over B. Okay, we always take the opposite sign of this. So meaning, since C is negative, our phase shift is positive. Okay, so take the opposite sign, and it's C over B. We also call this the horizontal shift of the graph, so it's the same as phase shift. D is our vertical shift, and we don't change the sign here, we keep the sign. Now, at the same time, we will be identifying all the properties of our function later on. So let's say, for example, you have this function y equals 16 minus 14 sine 2/3 x. Now, even if it's written irregularly, supposedly, I can actually express it in standard form like this, and it's the same. Okay, so it means that our vertical stretch is 14. Okay, you take the positive because it only means that our graph is reflected. And this is a vertical stretch because 14 is greater than 1. So by a factor of 14, our graph will stretch. And our B is 2/3. But we don't have C. That means our C is 0. So therefore, our phase shift is equivalent to C over B, and that's 0 over 2/3, which also gives us 0. So that means our graph is steady in the origin. So it's not going to move left and right. Our vertical shift is 16. That means our graph will go up by 16. Okay? Apart from that, we will identify the properties of our function so as we can review ourselves. So our amplitude here, so amplitude is equivalent to 14. Okay, we always take the positive because amplitude is a measure of distance, so it should only be positive. It's just that this graph was being reflected. Okay, so we will identify the minimum and the maximum because it's going to help us the range of the function, meaning to say it will help us the limitations of the values of y. So what we can do is just simply plug in our function with 1 and -1 because the maximum and minimum value of sine and cosine is just 1 and -1. So that will be 2. And then you have -14 times -1 plus 16 will give us 30. So that means this is our minimum and this is our maximum. That will give us a range of 2 and 30, meaning the values of y are limited to the numbers 2 to 30. Okay? And the last one is finding the period of our function. So the third is finding the period, and it's being represented by the formula 2 pi over b. And we know b is equivalent to 2/3. So that will be 2 pi over 2/3. And so we need to reciprocate 2/3 because we're dividing. So that's 2 pi times 3 over 2. So that's cancelled, giving us a value of 3 pi. Now, of course, you can always graph your function so that you can really verify the shifting of our graph, provided that this graph, this function is in radian. So you have y equals 16 minus sine. Okay, don't write it because it doesn't work that way. Sine x. And of course, you will have here the graph. As you can see, it was shifted 16 unit up because our midline is 16. So our midline is also equivalent to y equals 16. So the graph divide our function into two equal parts at y equals 16. So that means also that from this point up to the highest peak is 14 units. So as you can see, our maximum is at 30 and our minimum is at 2. Okay, so if you're going to add 3 plus 2 divided by 2, you will get 16. And then from this point, you count 16 to 30, and that will be 14. And that gives us the amplitude of the graph. Now, looking at it, our graph did not shift. And if you have a sine function, that would be from here to here. So that is our period. You have to identify the 5 critical points, not including that. So 1, 2, 3, 4, 5. So that gives us 3 pi as our period as we have computed in our function. Cosine pi over 3x plus 3 minus 12. This is conventional when it comes to its form, but when it comes to locating the period, it's not conventional. So I'm going to explain it to you later. So 15 is our vertical stretch because 15 is greater than 1. So this actually stretches by a factor of 15. And of course, 15 also represents the amplitude, which is equivalent to 15. If it's negative, it would still be positive because it's a distance. If it's negative, it only means a graph is reflected. Now, to find the phase shift, we need to find C over B, but we have to take the opposite sign of C, and that's negative 3 over pi over 3. Then, of course, we need to reciprocate this. That's negative 3 times 3 over pi, and that's negative 9 over pi. That means our graph will shift to the left by 9 over pi. So we will identify that later on through its graph. So this one is our vertical shift. All right, so it's a shift. And it also represents our midline at y equals negative 12. So this is where your graph will be cut into half. All right, now we will find the range of the function by giving the minimum and the maximum. So we will replace the whole function, the main function, with 1 and negative 1. So that's 15 times negative 1 minus 12. So this gives you 3, and this one is negative 27. So therefore, our range will be from negative 27 to positive 3. Negative 27 is our mean, and this will be our max. Okay, now is the time for us to find what is the period of our function. So the period is represented by 2 pi over b, and our b is pi over 3. So that will be 2 pi times 3 over pi, which is equivalent to 6. Okay, now this is a cosine function. It means that one cycle of a cosine function looks like this if it's positive, and if it's negative, it looks like this. Okay, where a sine, although I'm not very good with cosine, I'm not very good with drawing, a cosine looks like this. So that's one cycle. Okay, and of course, if it's reflected, you just have to reflect it. So this is a sine, and this is a cosine function. Okay, so let's go to the graph now. All right, so I have here the equation cosine 3 pi x plus 3 minus 12. Now, the midline is y equals negative 12. As you can see, the highest peak of the graph is 3 and the lowest peak is negative 27 here. All right, negative 27, which says our minimum and our maximum. And of course, we know that this is negative 12, and the distance between negative 12 and positive 3 is 15. That's the reason why our amplitude is equivalent to 15. Now, talking about how to identify the period, we know that the period is 6, but if you're going to look at the graph, this is a sine function, and this is our first critical point, which is negative 2.865. How do you know that? That's actually our horizontal shift. So if we will divide negative 9 divided by pi, okay, you would see that's equivalent to negative 2.86, which is actually the horizontal shift of the graph. You can see it here. Now, from the horizontal shift, the first horizontal shift to the left, this is our first critical point. This will now represent the zero of the function because you shifted it to the left. And then identify the 5 critical points to the right. And notice that the last number is not 6 but 3.135. I told you the period is 6. You might be wondering why the last number is not representing 6. Remember that your graph shifted to the left. Therefore, the last critical point will not represent 6. 6 represents only that after 6, the values of the function repeats by themselves. So let's say, for example, my cosine negative 2.83 is a certain value which is equivalent to 3. Therefore, after cosine 6, you will go back to 3 again as the value of the function. That's the meaning of a period where it repeats. Now, to find out really that this is correct, that this should be the last critical point, we will subtract 6 minus 9 over pi. And as you can see, it's equivalent to 3.135, which is the last critical point of our function. So that's how you understand how to identify the critical points of a cosine function, and of course, how to identify the period of the function through the graph by means of the shifting of the graph from left to right.